Welcome back, everybody. Thanks for gathering with me around the telescope. Next article for our news roundup for this week is Sniffing Out Life Across the Void of Space, the Cosmic Void. It was an article that came out this week. Found it very interesting. And it's one of those questions that I think as a species we have asked and wondered about, especially a lot over the last 150, 200 years. Are we alone in the universe? The first question related to this was if our sun was the only star to have a solar system of planets around it. Over the last 30 years, we have definitely solved that question with a resounding no. We have found over 6,000 exoplanets that are orbiting around their host stars. We currently can work out the temperature of these planets when we know their distance from their host star, since we know that Earth has a relatively mild temperature and as a result is the only planet in our solar system to have liquid water, we believe a component necessary for life. We can assume that planets with mild temperatures can be considered as possible candidates for having liquid water. Currently using quantum mechanics, we can identify the molecules in the atmosphere of these exoplanets because each molecule makes its own pattern and can be seen when the planet transits its host star and we get light through the atmosphere and we examine that atmosphere. If there is more of a molecule in the atmosphere or a higher concentration, then we can assume that's pretty abundant. If there's a lesser amount of that or a pattern for smaller concentrations as the molecule declines. For example, Earth's atmosphere is dominated by diatomic nitrogen, N2, but this molecule has a feeble barcode compared to the much less abundant diatomic oxygen, ozone, carbon dioxide, and water. Planets that are between the Earth size to Neptune size are the most common type of exoplanets that we have identified and found. One of these planets recently, you may have heard about it, K2-18b in 2025, had a bold claim made to it using this method of finding a molecular signature. On KB18b, dimethyl sulfate was found and was very abundant. On Earth, dimethyl sulfate is created by photoplankton, but sunlight rapidly breaks it down. On K2-18b, which is considered to be a water world, mainly covered in water, if not all covered in water, this was initially thought to mean that there was abundant of microbial marine life present on that planet. Other observers, researchers, and astronomers from the University of Arizona re-examined that data, and they found the choice of molecular barcodes to include in the analysis radically altered the results. They found that numerous alternatives not explored in the original paper provided equally good or even a better fit to the measured data. As great as the James Webb Space Telescope is, it struggles to detect an atmosphere on rocky exoplanets like Earth. That is why the development of other space telescopes, like the European Space Agency's Plato telescope, will be able to identify exoplanets that are more Earth-like and more fit for spectroscopy than those we currently know of. NASA's Nancy Grace Roman telescope, which will hopefully launch about 2029, will pioneer corneographic techniques where the telescope blocks out starlight so we can detect even fainter planets around other stars. The ESA's, or European Space Agency's Ariel telescope, which is planned to also be launched around 2029, is to be dedicated to the transmission spectroscopy mission, which will be able to determine the compositions of exoplanets' atmospheres. Thus, the future for looking for life in our galaxy is looking pretty promising as we continue to invest and bring a lot of these new telescopes into the equation. So the search for life continues. People will continue to see what they can find with it, but it's a good reason why we need these other telescopes to come on. And hope you have clear skies. Hope you keep looking up and continuing asking questions and looking for answers. Have a great night.